Hello and happy Monday. Mondays aren't so bad when you can stay in your PJs, right? All right, couple of reminders before we get today's lesson started. I need all of you to turn in last week's warm-up if you completed it. I see that a lot of you did complete it, but some of you didn't turn it in. Second thing is to complete your reviews. Your reviews are the Google form that's attached to every single assignment that I post. You'll have one of these every single day, so I need those to be done because those are currently being graded, and I'm missing quite a few. Number 3, do your quiz if you haven't already. If you have no idea what I'm talking about, just pause this video, go back to Friday's post, and complete that as soon as possible. Those grades will be up later today on the portal. 4, join my Remind group if you haven't already. Text this number, 81010, and say this, @Miss Nystrom. Lastly, follow me on Instagram. I made an Instagram page so that we can stay in closer contact. I'll be posting reminders, pictures, Instagram stories, trying to work on my Instagram game. Not that I have much of it, but we'll see. Extra bonus points if you join my Remind group and you follow me on Instagram. All right, and I'm instituting a bonus challenge for today. Please send or post a picture of you completing math work online. If you don't have an Instagram, you can email me the picture. If you do have an Instagram, please follow me and then either post it to your story or your page, or you can send it to me in a message if you don't feel like making it public. Totally get that. You'll get 5 extra bonus points for doing this as well. Troy, or TMS, I should say, wants to feature you guys doing TMS work. We have a lot of elementary students who are sending in pictures of them doing work, and I would like to show off that my middle school students are just as hardworking, if not more, and I would like a picture of you have to be in it, doing my, specifically, of course, math work online. And again, it may be featured on the Troy Facebook, possibly. I'll try to do something fun every day, a challenge. All right, so let's get to the warm-up. Also, sorry if you feel like I'm speeding through this. I don't have a ton of time, and today's lesson is kind of long. All right, so Monday, the objective today is I can find both independent and dependent probabilities. It says a store owner made a list of the number of greeting cards sold last month. The store sold 167 thank you cards, 285 birthday cards, and 56 blank cards. Based on these data, which number is closest to the probability that the next customer will buy a blank card? So we need to find the total, because remember, probability is always based on the total number on the bottom, and then favorable, meaning what they're asking for, on the top. So let's add those together. Hopefully you did this. I did not yet. I don't have my calculator. Here we go. 167 plus 285 plus 56. That gives us 508. So again, that's my total number. And they're asking specifically for a blank card, which would be 56. And then divide 56 by 508, and you get 0.11. Bunch of numbers after that. We would round that to 0.11. They do have it as a decimal. If it were a percent, it would be 11%. So the answer here is letter A. All right, jumping into the lesson. This is lesson 5. It's called Independent and Dependent Events. Sometimes it can get a little bit confusing. We're talking about 2 different probabilities. This is otherwise known as compound probability. You'll see that somewhere. Compound probability means that there are 2 events happening. So, the first question says, a coin is tossed 5 times, and each time it lands on tails. If you flip a coin the 6th time, what is the probability that you get tails? So hopefully you're thinking, okay, so you toss it 5 times, landed on tails, does that matter? Your chances, or does it affect your chances of getting tails the 6th time? The answer is no. No matter what, you're always still going to have a 1/2 or 50% probability of getting tails, no matter what happened the first 5 times. So when one event does not affect the outcome of the other event, the events are called independent. So independent events are two events that have nothing to do with each other. So spinning a spinner doesn't have anything to do with rolling a number cube. That's a coin. Flipping a coin, that's not how you spell it, has nothing to do with spinning a different spinner. And you can probably think of two on your own. So, write an example or draw an example of an independent event. It's literally two events that have nothing to do with one another, which could be pretty much anything. Okay, so let's try one. So one letter tile is selected from this group right here. And then the spinner is spun. So those are two independent events. They have nothing to do with each other. What is the probability that both will be a vowel? Okay, so find the probability using a tree diagram. Go ahead and make your tree diagram now, and I will do the same. All right, here is my tree diagram and my sample space. The question said, what is the probability that both will be a vowel? So, excuse me, we're looking at my sample space. We're looking for two vowels. So we have here, here, and that's it. So that would be 2 out of, how many total outcomes did we have? 12, which simplifies to 1/6, which I'm sure some of you have memorized at this point, is 17%. So letter B, find the probability using multiplication. So the probability selecting a vowel. So again, we're going to be doing the same thing, but in a different way. So we're finding the probability that both will be a vowel, but we're using multiplication instead of using a tree diagram so that we don't always have to write out a tree diagram. So selecting a vowel for this one. So if you look at that, how many vowels are there? 2. How many total tiles are there? 4. So 1/2. The probability of spinning a vowel, there's one vowel, A, out of 3 spaces. So to find the probability of selecting a vowel and spinning a vowel on both, we would use multiplication to find our answer. So take that, so probability of selecting a vowel, times the probability of spinning a vowel, 1/2 times 1/3, you end up getting 1/6, 17%, which is exactly what we got here. So we just found the exact same probability, but we used multiplication to solve it. And that is how you find compound probability, is multiplication. So let's flip the page. Whoops. That's what this says right here. So probability of independent events. So if A and B, meaning one event and two event, event 1, event 2 are independent, meaning they have nothing to do with each other, you find the probability of event A, multiply it by the probability of event B. So multiply. And Hank's barking downstairs. All right, so let's practice a couple independent probability. So for exercise 1 through 6, a number cube is rolled and the spinner at the right is spun. So this is event 2, and then that's a terrible circle. Number cube is rolled. Those are options. So find each probability. So hopefully you're thinking, okay, these are two independent events because rolling a number cube has nothing to do with rolling or spinning a spinner. So probability of landing on 1 would be event 1. So event 1 comes from the number cube. So how many 1s are there? 1. How many sides to a number cube? 6. The and tells you, okay, I need to multiply. And landing on A in the spinner. So 1, because there's only one A, out of 4 spaces on the spinner. So 1/6 times 1/4 is 1/24, and that is our answer. Number 2, probability of rolling a number cube and landing on an odd number. So again, the first event is talking about the number cube, and then the B is talking about the spinner. So you're finding two different probabilities and multiplying them to get your final probability. So landing on an odd number, We have 1, 3, and 5. That's 3 out of 6, which is 1/2. I'm just going to erase the 3 out of 6. And the N tells you to multiply. And B, or spinning on B, you get 1B out of 4 spaces. 1/2 times 1/4 is 1/8. Okay, number 3 is the last one I'll do with you, and then I'll do 7, and then the rest I want you to practice. So prime number and D. So prime number, a lot of you guys got this wrong on your quiz. Hopefully you know that prime numbers start after 2. So 2 is not, no, after 1, sorry. So 2 is a prime number. 1 is not. So prime numbers in 1 through 6. So again, this is talking about the number cube. So prime numbers would be 2, 3, and 5. So that's 3 out of 6, or 1/2. The and tells you to multiply. D would be 1/4. So 1/2 times 1/4 is 1/8. All right, so I would like you to try 4, 5, and 6 without me, but I will do 7, and then that way you can do 8. So you'll have 4, 5, 6, and 8 to practice. So number 7, what is the probability of spinning the spinner above 3 times and getting a vowel each time? So this is just talking about the spinner, but we're talking about 3 independent events, because whatever you get on the first spin doesn't matter what you're getting on the second spin. It doesn't affect it. So getting a vowel each time, there's 1 vowel. So on the first spin is 1 out of 4. On the second spin, still 1 out of 4. And on the third spin, it's still 1 out of 4. So 4 times 4 times 4 gives us 64, so 1 out of 64. All right, so I'd like you to try 4, 5, and 6. Meanwhile, I'm going to go on because I'm probably running out of time. YouTube only allows me a certain number of time videos, so I want to, not to rush, but I want to make sure I get it under 15 minutes. So dependent events, when one event does not, nope, that's totally not what it says. So dependent events are the opposite of independent, where one event does affect the outcome of the other event. The events are dependent. So it's the opposite. So whatever happened in event A is affecting event B. So you have to think about that second probability, which changes after the first probability. So let's try some so you see what I'm talking about. Sorry. All right, so example, there are 4 oranges, 7 bananas, and 5 apples in a fruit basket. Ingrid selects a piece of fruit at random, and then Terrence selects a piece of fruit at random. Find the probability that 2 apples are chosen. So thank you. 4 oranges. So orange, 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 orange. 7 bananas. That's 5, 6, 7, and 5 apples. So we have to figure out how many total pieces you have, which 4 plus 7 plus 5, that's 9. That's 16 pieces. So Ingrid selects a piece of fruit at random. So she is selecting, find the probability that 2 apples are chosen. So probability of 2 apples. So the probability that I'd pick 1 apple is, out of 16, 1, 2, 3, 4, 5. 5 out of 16. Now, Ingrid has the apple, so we lose one of these apples goes away because she now has that apple. The probability that Terrence selects an apple is now different because how many fruits do we now have? Well, we lost 1, so if you count up, you have 15, and then so we have 4 apples left because, again, the first person took it, Ingrid took it. So it becomes 5 out of 16 times 4 out of 15, which is 1/12. All right, I have almost no time left, but let me try. We'll read this to yourself, and I'll try a couple examples with you. All right, so the total here was 8. So if you pick a black sock, there's 3 black socks out of a total of 8 black socks.